Hello all. In this session, we're going to understand multicollinearity. What is this multicollinearity? How this will get handled? And what exactly is the problem of multicollinearity? We're going to understand this. Now, what is multicollinearity problem? First of all, what is the reason of what exactly is this multicollinearity? Let us understand. Multicollinearity meaning, let us say there is a data set. And there are two features or two variables which is x and y, which are x and y. Now the thing is, if x and y are being affected, once one is being affected, for an instance, let us say x is being affected. The amount that x is being affected by, by which the x is being affected, y also is being affected by the same amount. This is called multicollinearity. If x is being affected, similarly, at the same rate, y also is being affected. This is what multicollinearity. This is not an advantage, rather this will be a problem because one of these features will completely be waste, right? So if x is talking about the entire feature than y, or y is talking about the entire feature than x, now it is always better to discard one, right? Okay, if both, in the other words, if both x and y are related with each other, we can completely discard one because we'll be able to reduce the dimensionality and we'll also be able to handle several other problems if x and y are highly multicollinear with each other. So let us understand. So what exactly is this multicollinearity? Let us understand. Multicollinearity refers to the situation statistical modeling where two or independent variables in a regression model are highly correlated. This means that one independent variable can linearly predicted from another with a significant degree of accuracy. I told you x is being affected by a specific degree, degree. At the same degree level, y also is being affected, simple as that. Multicollinearity can make it difficult to determine the individual effect of each predictor on the dependent variable. Now the thing is, let us say y is equal to a plus b plus c. Now the thing is, what is the effect if a, b and c are highly correlated with each other, we don't know what is the contribution of these independent variables a or b or c directly onto the y. This is the biggest problem, okay, leading to unreliable estimates. Now, what are the basic causes of the multicollinearity if you understand? High correlation between variables will happen when independent variables are strongly related to each other. This is what we discussed. When two independent variables x and y are a and b, let us say the same thing is x is equal to a plus b plus c. These three are strongly correlated with each other. Now the thing is, when independent variables strongly correlated with each other, when these are correlated with each other, there will be a collinearity problem. And dummy variables, we are going to discuss about the dummy variables in the very next session. That understand, there also is a significant contribution of the dummy variables towards this multicollinearity. When dummy variables used for the categorical data are improperly designed. Now, we just need to understand, in the data, we may also need to define some dummy variables to handle or to take care of a few things. When these dummy variables are improperly designed, there may be a problem arises such that there may be a possibility of multicollinearity. So the improper design of the dummy variable may also lead to this multicollinearity problem. Data collection issues, insufficient sample size or poor sampling design. Now, whenever data set is being divided into several samples, the first thing that we need to make sure that the sample size must be appropriate. If you poorly design the sample size, there may be a multicollinearity problem. Mathematical relationship, when variables are derived from each other, such as including age and years of experience. Now these two variables highly are related with each other, right? Let us say there are two variables. One variable is age and one more variable is years of experience. Both relates to each other. When years of experience rises, age also rises. Age rises, years of experience also rises. Now, it is highly impossible to predict the effect of the age or years of experience independently towards the model, right? The dependent variable. The effects of multicollinearity are as follows. Unstable coefficient. Small changes in the data can lead to large changes in the regression coefficients. There is something called, of course, you know what is the regression coefficient. These regression coefficients will badly be affected by this high multicollinear variables. Reduced interpretability. It becomes hard to assess the importance of each predictor. Model prediction always is a key thing in a classification or regression model. In the machine learning models, the key thing is the model prediction. In machine learning models, accuracy plays a vital role, right? And accuracy will get affected. It is what interpretability, right? The accuracy will badly be affected, will come down significantly if multicollinearity is observed in the data. Inflated standard errors. There definitely be some errors. We discussed about errors. The contribution of the errors towards the model will rise when with respect to the multicollinearity. Makes hypothesis testing unreliable with the predictors potentially appealing insignificant even if they are important. Now there is an error. There is a predictor. The prediction, the contribution of the predictor is vital towards the model prediction. But due to this multicollinearity, the importance of a predictor may get subsided, thinking that it may not be contributing good to the model, although it is very a valuable predictor towards the model prediction. How to detect a multicollinearity? We'll go for the correlation matrix. There is something called a correlation matrix through which we'll be able to predict the multicollinearity. Check pairwise correlation between the predictors, high values. High values may indicate multicollinearity. Now the thing is, let us take X and Y, or Z, or A, or B, or C. These are the variables. Now what we need to do is, we need to take the pairs of each variables and we need to identify the collinearity. High values greater than 0.8 or less than minus 0.8 in any ways. If the collinearity factor is anywhere in between plus 0.8 to minus 0.8, beyond, because you know that signature, either it is positive or negative, doesn't make a sense. So what we need to do is, if it is 0.8, we need to understand that these are multicollinear. Variance inflation factor, there is something called VIF. We should be able to calculate variance inflation factor. There is a formula for VIF, that is 1 by 1 minus R square. By using the formula, we will have to calculate VIF. A VIF is greater than 10 often signals or indicates significant multicollinearity. Right after you calculate variance inflation factor, if the value is greater than 10, of course, it is significant multicollinearity. There is something called eigenvalues. Near zero eigenvalues, you know what is the eigenvalues, right? Eigenvalues and eigenvectors. There is an eigenvalue, and eigenvalue of the covariance matrix suggests the multicollinearity. Near zero, if eigenvalue reaches to 0, that means that it is multicollinear. These variables are multicollinear. Condition number. There is something called a condition number. If the condition number is greater than 30, is often problematic. We'll understand this right now. Okay. Now, how we'll handle this multicollinearity? How we'll be able to outcome this multicollinearity? There is something called remove the variables. If X and Y are highly correlated with each other, highly multicollinear with each other, removing either X or Y can address this problem. And combine the variables, create a composite index or principal component. X and Y are related with each other. Now, you combine this variable together and form Z. Now you'll be able to remove X and Y, will create only one variable. The first method is either remove X or Y. The second method is combine both and create a composite variable. Ridge regression adds a regularization to the regression to address multicollinearity. We also can solve this problem by the ridge regression. We'll understand about the ridge regression in the upcoming session. Increase the sample size. We also understand that multicollinearity may arise with the insufficient sample size. If we can have the sample size sufficient, it sometimes may overcome this multicollinearity problem. Centered data, standardize and mean center the predictors to reduce the correlation. There is a predictor, make sure that all the values of the predictor have actually been centered to the mean. Then it will be handled. Okay, now let us take a real world example of the multicollinearity by using the Boston housing data set. Okay, now let us understand what is this Boston overview, Boston data set. The Boston housing data set is a company uses the data set for regression problems. Okay, it's a real estate company. There is a data set where we have the houses, their prices and all the other details. By using this data set, we'll understand a multicollinearity problem. Information about housing prices and the various predictors like crime rate, average number of the rooms, tax rates and more. Now, the target variable is the price. Here, the prediction should happen with respect to the price. We should be able to predict the price. Our model should predict the price, which represents the housing prices. The predictors including the features such as CRIM, per capita crime rate, tax, full value property tax rate per $1,000, because tax rate will vary from place to place. The full value property tax rate for $1,000, RAD, index of accessibility to the radial highways. Now, what is the proximity of the property to the highway, which is defined by RAD. Now the thing is, step 1, detecting multicollinearity. How will we be able to detect a multicollinearity? Let's understand. Now let us go for the correlation matrix. A correlation matrix is visually represent the relationship in between the variables. Strong correlations between two predictors, tax and RAD, indicates potential multicollinearity. What is the RAD? Tax is for $1,000, for $10,000, what is the tax? What is the RAD? RAD is just what we discussed. Index of accessibility to the radial highways. That is, what is the proximity? How close our property is to the highways. And both goes hand in hand. Let us say this RAD is directly proportional to the tax or tax is directly proportional to the RAD. And that makes RAD and tax, X and Y, are highly related with each other. Okay, now take a tax. For this, computed VIF value is 336. For RAD, VIF value is equal to 134.426. Indus, VIF value is 77.261. The high VIF values for tax and RAD confirm multicollinearity. That is, there is a VIF value, the computed VIF value between tax and RAD indicates multicollinearity. Now, how will we be able to address multicollinearity? Remove the variable. Since tax and RAD are highly correlated, we can drop one of them. We simply can drop one of them, either RAD or tax. If we can remove one of them, we will be able to handle this multicollinearity effectively and efficiently indeed. After removing RAD, VF values for the remaining predictors are recalculated. Now the thing is, tax VF will be 10.459, Indus VF will be 8.561. Okay, this is how we will be able to handle multicollinearity problem. Thank you.